Hello, everybody. We're going to be working on the last couple of exercises in the arrays and loops playground. And if you remember last time we were together, I put forth the challenge that you guys finish these on your own. And I know that maybe they're a little bit more challenging than you gave them credit for. And then you also get this effect where you step away from it for a while and you kind of forget what you were doing and what the stuff was. And so there's going to be a little bit of pseudo lecture kind of thrown in as I'm kind of putting this code together. I am working from the teacher's solution just to make sure that I stay on track and kind of shoot for the target that they want us to hit. But there's a few different steps in this process. So there's, first this concept of like what an array is, so that we're going to revisit that concept, and then also the process of setting up processing steps, both in the form of functions and in the form of loops to process the information that we're putting into the arrays. If you remember, an array structure is it's kind of like a variable or a constant in that you can store something in it and give it a name. Same types of information we would typically store: numbers, words, booleans, etc. But an array structure allows us to store multiple values under the same name, with each value being accessible by its index value in the array. The array indexing always starts at the number 0, and then we count up from there. So let's do the first task here, and it says create an array literal with 20 to 25 items of sample data for your daily activity. It might be something like miles biked, and then you can kind of do a thing. Now, you know what? I'm going to go with their example. I don't ride my bike as much as I used to, although we did fix up all our bikes this summer, so they're kind of poised and set to go. But I tend to hike more than bike. So I think it's kind of interesting. This gives you a chance to maybe apply it to a real world situation if you wish. Now, they give us some sample information here, and real frankly, it's silly of us not to just directly copy it, because it's kind of given. So if you didn't figure this part out yet, I'm going to go ahead and copy this. It will throw an error, by the way, because that ... is not code, right? But whenever you see that in a coding book, I always tell my students what that indicates is, and the rest of the code is ... right? They're not giving you all of it, but the challenge is to come up with 20 to 25 items. So what I'm doing is I took the first few values that they put together, and then I'm grabbing the rest of these from the instructor's solution file, by the way. For those of you that are here in the session with me live, here's the additional numbers in the chat, so you don't have to type them in. I think you might appreciate that a little bit, or save a little time. But here we have a conglomeration of values. There are 20 elements in this array. You can see that in the sidebar. Swift is really good about, playground at least, of showing you that array structure and how many elements are in it, so you know that you have 20. Now, it's kind of interesting, as we build this, because they're making this point of saying, hint, make sure to choose the right kind of array for your data, whether double or int. Do you guys remember how to check the data type of an array?
Oh, what was the click? Is it option click? Yeah.
Yeah, it is option click.
Oh,
So
command click.
yeah, so you just hold your mouse over the named structure, hold on option click, and it tells you that this array holds doubles. So even though I do have integers in here, they are being treated as floating point numbers. So in other words, 3 is actually 3.0, right? And that happens automatically. Swift does an automatic conversion. I was reminded rather crudely during my Tuesday evening class last week, because I'm teaching C# again for the first time in a while. And in that language, you cannot even do math with mixed data types, and so there's like all this like heavy conversion that you have to do in order to like perform any operation. Very frustrating. However, it leads to program integrity. Swift kind of handles a lot of that automatically, so we should be thankful of that feature. It's almost Python like in that capacity. All right, let's look at the next task. It says, write a function that takes the daily number as an argument and returns a message as a string. It should return a different message based on how close the number comes to your goal. You can be as ambitious and creative as you like with your responses, but make sure to return at least 2 different messages depending on your daily progress. So this is open to interpretation. This is kind of the point. So like if your daily goal, for example, when I walk, and here I am, I have my smartwatch in my pocket instead of on my arm today, and that's kind of a mistake, right? But I have a smartwatch that I, syncs up to my phone and keeps track of my steps. And I have this, kind of, it's considered like you're kind of sort of physically fit if you can do 5,000 steps a day. So my daily goal for walking is 5,000 steps, right? If I can hit 10,000 or more, even better, right? And then if I do like a long walk, like a 5-mile walk or something, I easily clear 10,000 steps. So for biking, I'm not really sure what a good equivalent value is, but I think maybe like a 5-mile bike ride, I think is a good minimum, right? Certainly if I was on my feet, I would, that's a long walk. 5-mile walk is enough to kind of tucker you out for sure. On a bike, that's not really even that much. Depends on, uphills and downhills. But let's set up a function that is going to determine whether or not we've reached our goal. All right, so here's how I'm going to proceed. I'm going to say func, and then I'm just going to call it goal achieved. Did I spell achieved right? Yes, I before E, right? And then we're going to set up some parameters here. And we were told up above what those parameters should be, because it says it takes a daily number as an argument. So, hey, you know what? That sounds like a great name for something, daily number. And because all the values up above were in the form of doubles, that's the data type that we want here. So I'm going to enforce that data type. So it's going to receive one of those double values. And then ultimately what it's going to return to us as a function is a message as a string. Curly brackets. So there's the function setup. Right. Now, yeah, right. Yes, I am missing a return statement. So you're seeing the error message pop up, but I'm going to get to that. That's going to be, in there. It says that you should return at least 2 different messages. My thinking is I'm going to set a goal of 1 mile or 5 miles or something like that. And I either meet it or don't meet it. And I can check it with an if statement. And then each part of the if statement, the if and the else, can give me a message, and I'm kind of done. So it's not very complicated, really. So what I would put here is, let's set a goal. So I'm going to say, let my goal equal 5.0. And that seems like a reasonable goal, 5 miles. Now let's just check it. Let's say if the daily number is greater than or equal to the goal, that's a good thing, I think, right? Because we're hitting the goal. Then let's return a statement. And I'm going to copy paste this in, by the way, just for efficiency's sake. You guys can do the laborious task of typing it in. Right, you've reached your goal, right? Which is great, because this is either you've reached it or you went over, and you went over your goal by, look at the math. There's a little bit of math here. So there's string interpolation going on, right? So this is how we feed in daily number. But this is something we haven't seen yet here in Swift. I can also take another variable, do a little bit of math with it, and drop that into that spot. So I'm taking the daily numbers, subtracting the goal. So if I went 7 miles, this would say you went over your goal by 2 miles. And I think that's kind of cool. Then we'll have an else. So either you met your goal or you didn't meet your goal. You could put more fine gradients in here. So like if you were close, you could say, hey, you almost reached your goal. Or if you just got over it, you made your goal, try to get better. Or if you went way over, you could put in like 20 different messages. It depends on how encouraging or discouraging you want to be, right? And then for the else here, because we didn't reach the goal. We want to have some sort of a message. It says, hey, too bad, or whatever. And this is, unfortunately, you did not reach the daily goal of blank miles. And we're using string interpolation once again to drop in that goal. And so you could change that number if you wish, or if we change this from miles biked to miles hiked, you know, I would say like a good hiking goal would be like 2 miles, you know, for example, or a mile or something like that. All right, so that's our function. Slowly scroll and try to keep it in view here. In fact, I can expand the height here a little bit. And you know, this monitor is so big, I always forget the fact that I can, you know, I can really make this playground much, much bigger. You know, and the people on like watching this on YouTube, if all 3 of them, I think, that are watching it, it's not like it's going to be a huge audience, but that helps them, I think, a little bit. I can also zoom in if you guys are finding this too small. And if that's the case, please let me know. Now it comes the more challenging part, I think, because we figured out the array, figured out the function, pretty simple. Now we have to write a loop that is going to call the function repeatedly, checking each value in the array, and then returning the appropriate message. Right, so this is, okay, not as hard really as it might seem, but it's all in the reading. And it says write a for in loop, right? And just to give you a comparison to other languages, a for in loop is typically what we call a for each loop in other languages. It automatically looks at a data structure like an array and steps through each position and processes it through the loop. There's no need to set limitations or complicated for statements like we have in many languages. It just operates automatically, and it's a really beautiful thing when it's working right. So let's build that loop. We'll do a for, and I'm looking at my data structure, which is miles biked, right? So that's what we're going into. But every day that I do this, I'm going to call those my daily miles. And I'm looking in my miles biked array to do the processing. This keyword here, right, for daily miles and in miles biked, this is going to be a variable, right, that's going to be used internally inside the loop, right? So yes, right now it's throwing an error because, hey, you know, we don't know that it's being used or not. I want you to notice though that what it's suggesting as a fix, and this is kind of interesting because who's to say, you know, what we should name it? Like if you don't know, if you're still thinking about a name, you could just use an underscore, and that way it could use anything, right? Okay, so that's not really a good idea in this case, I think. The next thing that we have to do is really think about this. We're going to call the function. The function's going to take the value we're currently processing, analyze if it reached the goal or not, and then return a string to this spot that it's going to put on the screen, I think, right? So maybe a good thing to do here is just to simply print a result of the function running. And here's how we'll call it, right? So we'll say goal achieved. And you see how it auto fills everything. And I want that to happen. Right now, double is highlighted, so it's expecting me to put in what is the thing you're checking. Well, the individual thing from the array that we're checking, I decided I'm calling it daily miles. So I'm just going to drop in daily miles, which is the current position we're looking at. All right. Now, if you notice here, it processed it already, and you could take a quick look here, and I'm trying to keep the data in view along with all the code, right? So processes the 3. Yeah, that's not reaching the goal, right? 7.5, you've reached the goal, you went over by 2.5 miles. See, right? And you know what might be helpful, and this is just my approach on this. Like if I'm coding something, I usually, it's like, what data am I processing? Might be good to like put that back in the message too. Like, you've walked X miles, you've reached your goal, for example. So we could add that piece in, because that way, what process you've biked, right? We're biking here. Well, you biked. What would I use here? It would once again be daily number. Let's put this correctly here. And we'll just let that reprocess. And you'll notice only on the successful statements is it showing you that number. I would argue that, from the standpoint of the user, whenever you're putting stuff up on screen for a user, be verbose. People want more info, not less. Nobody's going to complain about having too much information. They will complain about not having key pieces of information. And this way, when you look at the output, you can determine, right, that is it reading it correctly and is it processing it correctly? And the first thing I notice is, hey, there's a couple in here where there's 0. Oh yeah, because there's a couple days where this person decided not to bike. Probably, Saturday and Sunday after going out with his friends or something, right? I'm not biking. I was out last night. Or maybe it was raining, or maybe it was, here we are in Wisconsin, maybe it was snowing. Right. So this is the solution for this exercise. All right. Let's move on to the next one. You guys all good with this? I can move ahead. Got it all in?
Yes.
Is it working for you guys?
Yes.
Yeah.
Okay, excellent. Good to hear. All right, let's move on to screening messages. And this one's got a little bit different scenario here we're going to follow through. So let's read what's going on first. And then that, in the reading, you sometimes get the answers here. Now it says, you've somehow come to possess a huge list of messages about a series of characters, caterpillar, dormouse, Cheshire cat, and others. This list is contained in Alice messages constant below. So in other words, this is given to us and it's defined basically in the background of the playground as an object. But you know what? You can kind of see it. So like, if you start reading this, in fact, maybe the better way to do it is like this, right? Right. So what is it we're really looking at here? Okay, not to spoil the surprise.
This
Yeah,
is
go ahead.
an array of strings.
It is. It's like an array of quotations from, Alice in Wonderland, basically, right? So there's 340 quotations. So somebody took quite a bit of time to create this, right? And so this is banked, basically, is the way I look at it. So this information is given to us. Why? So that we don't have to create it, basically. But we have this like pool of messages. All right. All right. So, and it says, try to print out all the messages ready to see the whole list, but where it's large enough that it may cause your playground to run slowly. I'm not going to do that, by the way, but the way you would do it is you could just drop a print command right here, throw Alice messages in it, and then it would read each one, put it on the screen, and show it in the console, right? I'm going to take it on faith because I don't want my playground to run slow. Plus I'm recording, yada, yada, yada. So, but it wouldn't take much to do it, right? But then when you are processing large data items like this, you always have to be mindful. I don't care how fast and powerful your computer is, and we're all on pretty modern machines right now, so it shouldn't really be that much of a processing lift, but it can be, right? And just beware that even processing text takes time, and this is a really large chunk of text. All right, so next thing says, the caterpillar has asked you to go through the messages and to relay any that contain the caterpillar's name, along with the message number. Instead of reading all the text yourself, you decide to write more code to help. And by the way, this is exactly the type of scenario that coders try to address often, right? And it's like, so like if you're tasked with looking at, okay, let's say there was like 10 messages, right? That's not a huge number. It's a whole lot less than 340. But if there were 10 messages, And you know what? I couldn't even read the entire line. I might do an output, print it to a screen, throw it up on the screen and just look, or drop it into a file and maybe do a control F to find, that's a possibility. But the moment any data structure gets so large that it's cumbersome to process, this is where coders get smart and go, you know what? There's a better way. There's a more efficient way. Just a matter of thinking about it for a minute and setting it up. So it says you'll use another kind of for in loop on this page. You're accustomed to the loop variable containing the items from the array, but in this case, you want to print the message number. So your loop will iterate over the index number as opposed to the message. That's kind of an interesting comparison, but this is a thing that happens too, because remember the task here, we're being asked to provide which message number contains his name, and then he can go look it up himself, right? So he knows where to look on the list to find it. All right. So they're giving you a little bit of an example here. So let's take a look at it. And it says, let colors equal all of these, right? So these are all the basic color wheel colors. And now instead of looping through colors, right, we're looking at, and once again, here's your ... Right. And in this case, this is functional, by the way, but we're saying for I, which is an unknown in 0 ... meaning from starting at position 0 in the colors array, we're going to operate basically through the whole thing. So let me explain what's happening here in terms of a property, because we learned in the last unit what a property was. Count is a property attached to arrays that counts how many elements there are. In this case, we have 1, 2, 3, 4, 5, 6, 7. I could have read that over here too, by the way. So we have 7 elements. And then there's a -1. Why are we subtracting 1? Because we want to start at position 0 and go to the last position. The last position is 0, 1, 2, 3, 4, 5, 6. So I couldn't, I can't put the count numbers inaccurate, in other words, because it's going to return 7. So I have to subtract 1 to get back down to 6. Very common in array processing, by the way. So what we're saying is for I running in the range from 0 to 6, this is really how it reads. So 0 to 6, we're going to go through and we're going to print out the index value and the color that goes with it. So if you take a look at the panel down on the bottom here, the console, right? So it's outputting 0, the colon, space, and then the color that's in the same position as the index value we just printed out. So what we're really doing is we're printing out the index number and what's inside, right? So cool. All right, I think that's marvelous. All right, so now it says the loop variable I, its values are defined by the range expression to the right. It uses the ... operator. So this is actually an operator. So, here I was just telling you just 5 minutes ago, hey, ... when you see that in code, it means, and the other code that goes here. In this case, it's actually functional. So when you see it in the loop statement, it's a range declaration. So it uses the ... operator to define a series of values starting with the 1 on the left and going up through the 1 on the right. To generate the indices of the array, the start range is 0 and the end is the last index, which is 1 less than the count of the array. That's a much more efficient explanation than the one that I had, but hopefully my explanation made some sense to you. All right, so here's our actual exercise. Create a for in loop to process the Alice messages array by iterating through its legal indices. Okay, so what that means, legal indices, well, how many, okay, so we know that the index value is going to start at 0 for those Alice quotes. What's the index value of the last position? To see if you guys understand the concept.
So
Yeah.
the index value of it would be the count -1, right?
Right? Correct.
Yeah.
So the count is 340. So the index value of the last position is
339.
exactly. All right. So that's a really important concept, you guys. All right. All right. So through its legal indices and the body of the loop, use the index to access a message from the array and check whether it contains the string caterpillar. If the message refers to the caterpillar, print it to the console along with its index. So basically the same thing we're doing here, but we're going to put the index number and the full quotation. That's what our output is going to be. So we have actually a model to follow that is really not that far off from what we have. All right, so let's come down here then and start building this. And I'm going to start with my for loop, and let's see if we can get the syntax of how the loop's going to run. We are going to run the index value. So we're using I. Real common, by the way, in programming, that I is the way we refer to these complicated structures, and it comes from the word index. And mathematics uses the same thing, by the way. So we're going to say for I in, and we're going to do the range. We're going to start with 0, right at the beginning, and then we're going to ... and we're going to look at the Alice messages dot count. So we're going to count it and subtract 1. Very similar to the color one. Very, very similar. Right. Now inside the loop, we're going to occupy a little memory here, and we're going to store the message in that given position. So we're going to actually, as we're going through this, we're pulling in the whole message. So this is going to take a little while to process, and this is kind of interesting in and of itself, but we're going to let the message equal our temporary placeholder, the messages in the current index position. So it's going to read each line. It's going to store it in a constant for processing. And then we're going to say if message, and here's one of these built-in methods, by the way, contains, this is a string method if you're wondering. And what are we looking for? We're looking for the word caterpillar, right? I always struggle with that one. It's like surprise. You always forget the first R in surprise. And everybody says surprise, but it's surprise, by the way. So we're looking at that. So if the current string that we have in the variable, constant, contains caterpillar in exactly that format, then what are we going to do? Then we're just going to print it out. That's all we're going to do. So we can copy the format we used above. We will do string interpolation. So I will do \I, and move out of those parens and put in a colon, and then I can drop in the message. Now, interestingly, I'm looking at the teacher's solution, and the teacher's solution is like this, which is concatenating the message. Right? Kind of strange, right? Because we could also use string interpolation for that, right? All right. So right now, you will notice down in the console, it is working using this approach. I am going to pop it out though, and then I'm going to do this approach and see if it works also. Close it. Okay,
It worked for me.
Yeah, it works just fine. There is a difference though in the output. And the output is when we're looking at it down below in the console, are you noticing that now instead of having double quotes around the statement, it's got a single quote, right? And did I mistype something? No, that's just how it is. And maybe that isn't great. I'm not really sure, right? So I'm going to go back to the author's approach, see if there's a perceptible output difference. So like, I don't know, it's kind of looks the same to me.
Yeah, it's still single quotes.
Yeah, it is. So that must be in the file that way. So it must be dialogue. Either way, you can use either approach.
I'm not getting what you guys are getting.
Okay. Let me
Oh,
pause the recording really quick.
all
Sure.
right.
All right, so hopefully here you guys got this to work. And if not, check your syntax really carefully. But this is a really cool little exercise and kind of a fun one. All right, so that will I think end our videos here. I don't think there's anything else at the end here. Oh wait, there is. We have one more exercise. I don't mean to like blow your guys' minds here, but we got one more to work on. Right, you're like, oh great, I thought we were all done. Maybe I'll have to increase the point count on this. All right, let's read through this one too. I don't think this one takes as long. So we had practice in the previous two exercises of working with a for in loop in the traditional way, a for in loop with the index numbers. Now we're going to switch over to a while loop to reinforce that skill. So let's look at the exercise set up here. It says there may be times a task doesn't require you to iterate through an entire array. Imagine, for example, you're going to produce a play based on messages from the previous page. The actor playing the Dormouse might want to know if their first appearance isn't until midway through the messages so they can sleep a bit later on rehearsal day. Your task on this page is to report the index of the first message that contains a given character's name. A for in loop will always execute its body for each element in the array. So even though you could use this type of loop to solve the problem, it'd be inefficient, especially for characters who appear early, right? Instead, you use a while loop. While loops are a bit like if statements that require a condition before the loop body. So the condition is evaluated before each iteration of the loop. And of course, if you don't set the condition correctly, the loop may never operate. Or it could operate if you don't change the state of that thing you're checking, it could also operate forever. So the first time it evaluates the false, the loop exits. The code below uses a while loop to calculate factorial numbers. Right. All right. So let's first take a look at this because this is kind of an interesting little exercise in and of itself. Factorial numbers, by the way, are this kind of special type of mathematical structure where if I take the factorial of the number 7, what that means is I'm multiplying 7 times 6 times 5 times 4 times 3 times 2 times 1, right? And you're what's the total of that? That's a factorial. So with this factorial, that's the number we're evaluating. We're going to start at 1 and the result is already preset to 1. So when we check to see is the number less than the factorial number to calculate, less than or equal to. If so, the loop will operate. So in this case, it will operate. It's already triggered to operate. So it will take the X, right, and then multiply it by result and add it back in. So does it matter in multiplication if I go 1 times 2 times 3 times 4 times 5 times 6 times 7, or if I go 7 times 6 times 5, it doesn't matter, right? You still have the same result, the same order of operation. So they're starting with 1 and counting up. I would probably start with the big number and count down. It's just a change of logic. So they run it, and basically what they're saying is the factorial for 7, and this is how it outputs, by the way. Factorials mathematically use the number and then an exclamation mark. That's the mathematical expression, right? If you multiply all that, you reach 5,040 as the value. All right, so that's great for factorials, but what about our other scenario here? So let's go back and keep in mind the Alice messages construct is still in the background of this playground. So we do have direct access to it by just referring to it. I'm going to suggest that we focus on the caterpillar. So let's call our character caterpillar with a capital C, which you guys, right? And caterpillar, with a R after the T there. And then, you know what? We're going to be looking at, as we do this, how long is this gonna run? I mean, because we, with the factorial, we preset like the top value. With Alice's messages, we already know there's 340 of those. So we're gonna count those, right? So as long as we're under 340, that should work, right? And so either when we're processing this, and this is not an easy exercise conceptually in terms of writing the while loop. I'll give you that and you'll see why in a second, but we do need to kind of keep track of both the index value in the array, and we also have to keep track of whether we found a message or not, right? Okay, so here's my setup. First, I'm going to create a variable, not a constant here, a variable, and I'm going to set its value for index to 0. That will help us keep track of our position. Why do we do this? And we didn't do this with the for loop. Well, the for loop keeps track automatically, right? This is the difference between a while loop and a for loop. With a while loop, I have to manually pre-configure the things to operate in the way I want. All right, so I'm setting the index to 0 because that's where I want to start, first position in the array. The other thing I'm going to set also is a Boolean value called found message. And you know what? We're going to start with a value of false because we haven't found it yet. So basically, seems kind of silly, but we haven't found it yet. The moment we do find it, that might be a condition for us popping out. Okay, so now we have sort of a condition in mind. The other thing is, as long as the index value is less than the count. So I'm actually gonna type that one in first. So I'm gonna show you my logic here. So I'm gonna type while index is less than Alice messages dot count. Now notice I'm just using less than, right? Alice's messages count is 340. The last index value is 339. So that will work. If I had an equal sign in there, then I'd have to add a -1 to it. You see the logic, right? So this will check everything from 0 up to 339. Right, but that's not all we have to check, because if it finds a message, then we could set a flag that says, found message equals true, and then that can terminate the loop too. I'm going to put that at the beginning, and here's the negation symbol, by the way. Not found. This is bad. Not. I'm going to do this again. Not found message. And then I'm putting the double ampersand in, which stands for and, right? So think about this. When I'm negating a variable, I'm referring to its opposite state. Its current state is false, right? Which, if I say not found message, I'm really saying true, right? And remember, when we're evaluating true false statements, we want this to trigger to true. So this part of it, the first part, will trigger to true right off the bat, because we're doing the opposite of what this is. The exclamation negates or flips the value of a Boolean. So this is not false, meaning true. And we're looking for the index value to be under the count. Also, both things, when we have the double ampersand, that's an and. So both sides of that statement have to be true for the loop to run. We haven't found the message, and we're less than the top index value, right? So hopefully that makes sense to you. All right, let's set up some curly brackets here, and now we will do some internal checking. So what we're going to check, and think about this, we're going to check each message one at a time, and then we're going to run the contains command to see if that character is listed. If so, we're going to set it to true and print out the index number. We don't need the message, just the index number of where it first appears. So let's type up that logic. So if the Alice messages index and now we're using the whole word here. It could be an I, but we're using the whole word. Dot contains. And now what are we looking for? The character that we preset. So if the message we're looking at currently contains that character, first we're going to take the found message Boolean and we're going to set that to true. Right. And keep in mind, once it's set to true and it goes back up to the top of the while statement, it will get negated, set to false, and then it won't run again. Right. That's the logic piece there. We're also, if we find it, we're also just going to print out what the index value is. So we're just going to print out that number and it tells us where in the array to look to find it. I could also print out the message if I wished. And we weren't asked to do that, so we're not doing it. Otherwise, if it doesn't find it, we're just going to increase the index number by 1 and check the next spot. The loop will loop. The found message is still, the not found message is still false, right? And will operate. All right, so this is basically the solution. Interesting. So what we're finding out here is that the first time that message is indicated in that big array of strings is at index number 151. Now we can actually validate that this is the case. Well, we could print it out and look at all those messages. That's one way, right? Total pain. But please remember that you, on the previous page, ran some code where you could actually go in here and look, right? So here's message 151, and sure enough, that's the first time, right? So this is your solution here, folks. Right here on the screen. Yeah, and I of course I was doing it on this other screen. So if you want to go back and take a look, right here, this is what I was referring to. I was doing it on my other screen in the solution, so I apologize. Making maneuvers and talking about them, but yeah, sure enough, right here it was on index value 151. When we go back to the completed version here, we do see it's at 151. All right, that ends this exercise solution video. So we covered the last couple of exercises here in the arrays and loops area.